All right, so the first thing you need to know about the unit circle is it is a circle that is centered at the origin. So its center have coordinates 0, 0. And the most important thing you need to know is that the radius of this unit circle is of length 1. 1 unit, whatever that unit may be, centimeters, inches, whatever, as long as it's 1. That's what's mainly important. And now really what I'm about to show you is how to go about finding the coordinates of all of the important points along the unit circle. I'm really going to focus on the points on one quadrant, and then you'll soon see how it's pretty easy to see how they follow from the first quadrant. All right, so to get the coordinates of the first point, I'm going to draw a line that's forming a 30-degree angle from the positive x-axis. And hopefully you realize that that 30-degree angle comes from the last video when we talked about 30, 60, 90 triangles. So we're actually going to use that in order to come up with the coordinates. So the first thing I'm going to do is draw a perpendicular line going down, and that'll make a right triangle, because you know perpendicular means it forms a 90-degree angle. So that's 30, that's 90, so this one has to be 60, making that 30, 60, 90 triangle that we talked about in the last video. All right, so if you remember, what I did was I let the side across from the 30-degree angle be x. And then if that was the case, then the hypotenuse was of length 2x. And then this side right here was whatever x is times the square root of 3. These are literally the same triangle, but what we can do here is we have to think about our properties of unit circle. You know that the radius is 1, right? And so that radius acts as the hypotenuse of this right triangle. So if I let this side be 1, then you can see that that 1 is equal to 2x. And so I can use that relation to find x, which will give me this side right here. And then I can take that x and multiply it by the square root of 3 to get that side right here. And so all I can do is just set up and say 2x equals 1. And then obviously I can divide by 2 on both sides to get x equals 1/2. All right. And so for this bottom side, I know it's whatever x is times the square root of 3. So if I do 1/2 times, and then I'm going to rewrite the square root of 3 as the square root of 3 over 1, just so you can see you're multiplying two fractions. Multiply across the top, that's square root of 3 over 2. And so this is going to be this side right here. And then my x is going to be a distance of 1/2. All right, so now when it comes to the coordinates of those points, just think back to when you learned about how to plot points. You started from the origin, and then you went right or over a certain distance and up a certain distance, right? So that horizontal distance is the square root of 3 over 2. And then we went up a distance of 1/2. So that's where those coordinates come from. And I know a lot of people who teach this, they like to just give you the coordinates off rip and tell you to memorize them. And I'm not saying it's a bad thing to memorize them, but I just want you to at least know where they come from. All right, so the next point right here is made from making a 45-degree angle from the positive x-axis. And if you notice, that looks a lot like the 45, 45, 90-degree triangle that we did in the last video. So if you remember, with the 45, 45, 90-degree triangle, if I let one side be x, the other side across from the 45-degree angle was also x, and then the hypotenuse was x times the square root of 2. Again, same concept. I know that this orange is a radius, and so its length is 1. So if I say that 1 is equal to this hypotenuse, which is x times the square root of 2, I can use that relation to solve for x just like I did in the last example. So let's do that real quick. Let's say I let x times the square root of 2 equal 1. And then to get x by itself, you know, I just divide both sides by the square root of 2. And you'll probably notice that I have a square root in the denominator, which a lot of people don't like. So we do what's called rationalizing the denominator. And the way we do that is basically just multiply this whole thing by 1, but you do it in a creative way to where the square root gets eliminated. And the way we do that is we're going to multiply it by the square root of 2 over the square root of 2, because you know anything divided by itself is 1. So if I just multiply across the top, x is going to be equal to the square root of 2 over the square root of 2 times the square root of 2 is just 2. So this square root of 2 over 2 is this length and this length if my hypotenuse is of length 1. So that means to get from this distance to the x coordinate of this point, it's going to be a distance of square root of 2 over 2. And again, I'm drawing a perpendicular line to make my right triangle. And then this is also a distance of square root of 2 over 2. All right, so to get the coordinates of this point right here, I moved over a distance of square root of 2 over 2, and then I went up a distance of square root of 2 over 2. So the x and y coordinate in this case happen to be the same, but that's what they are, square root of 2 over 2. Alright, so for this last point on the circle, it comes from making a 60-degree angle from the positive x-axis. And if this one's 60 and this one is 90, then that makes this one 30. Which again is a 30, 60, 90 triangle, but it's oriented just a little bit differently. Now, remember how I said that the side across from the 30-degree angle was x? And earlier we saw that x had a length of 1/2 whenever our radius was 1. So that's 1, that's 1/2, and then the side across from the 60-degree angle was 1/2 times the square root of 3, or the square root of 3 over 2. And so that's how I get my coordinates for that last point. I go over a distance of 1/2, and then I go up a distance of square root of 3 over 2. All right, so that's how you get the 3 main points that lie on the unit circle. Before I get into the other quadrants, just real quick, I want to show y'all how easy it is to get these 4 main points. So remember, the center is at the origin 0, 0, and the radius is 1. So if I move over 1, then that makes this coordinate 1, 0, because I don't go up at all. Over here, easily you can see how it's -1, 0. And then I go down 1, so this will be 0, -1. And then this point right here will be 0, 1. All right, now, for the rest of the points, if you can understand these 3, then the other 9 points are really easy, because if you think about it, just imagine these 3 points being flipped over. So now all the x coordinates are negative, because from the middle, I'm going to the left. All right, so for this point right here, it's the same thing as this point, but flipped over the y-axis. So the x coordinate is going to be negative square root of 3 over 2. And then since we're going up, that 1/2 is still going to be positive. And then for the 45-degree angle point, it will be negative square root of 2 over 2, comma, positive square root of 2 over 2. And then for the 60-degree angle, again, the x coordinate is negative, so that's going to be negative 1/2, comma, positive square root of 3 over 2. So again, it's the same thing as the first quadrant, except since we're going to the left, all of the x coordinates are negative, and then all the y coordinates are positive. And so for this point down here in the third quadrant, we're doing the same thing as before with the 30-degree angle. Now remember, that 30-degree angle is coming from the x-axis. So if you can imagine our angle starting here and then going down 30 degrees like that, that's how we get that coordinate point. So since I went to the left, it's going to be a negative square root of 3 over 2. And since I'm going down, it's going to be a negative 1/2. You probably already know that every point in the third quadrant is negative in both the x and the y coordinates. Now in the fourth quadrant, it's pretty much the same concept. Since I'm going to the right, my x coordinates are going to be positive, and then since I'm going down, my y coordinates are going to be negative. right, so that's pretty much how you fill out the unit circle in terms of its coordinates. Like I said, it does help to memorize it, but like I said, I at least want you to know where these coordinates come from and show you that they're not just random. There's a reason that these coordinates are the way that they are. Mainly just know that because the radius is of length 1, you can make a right triangle out of it and use these two properties that we talked about in the last video to come up with the sides of the other two legs in both types of triangles. One other thing you might want to know is the number of degrees that it's rotated to get to each point. So like you already know, this point right here is from a 30-degree angle. This point right here comes from a 45-degree angle. This point right here comes from a 60-degree angle. And then, you know, this point right here comes from a 90-degree angle. So the way I like to think of it is I go 90 plus 30, 90 plus 45, 90 plus 60. And then I know that 90 plus a whole nother 90 will get me 180. And then I just follow that same pattern throughout the rest of the circle. Alright, so take some time to familiarize yourself with this. Rewatch the video again if you need to. I would even recommend starting with a blank circle and seeing if you can fill this out based off of what you know about these two special right triangles. In the next video, I'm going to be talking about radians and how they relate to the unit circle as well. So stay tuned for the next video.